Hello again from Digicool Things. This is a follow-up to an earlier video where I experimented with using a cheap preheater for surface mount reflow soldering. Let's call this part 2, where I thought I'd do a teardown of the preheater to see what makes it tick. Since the last video, I now have a good reflow oven, but I've continued to make reasonably regular use of my preheater. Basically, it's still my go-to for single board reflow. When prototyping, doing board rework, and just for the easy recovery of surface mount components. It's just that it's sometimes really convenient to just have a compact, portable solution with full access to the board while working with surface mount components. So my actual reflow oven is mainly used while doing production batches of PCBs, where perhaps I'm doing, four to 8 boards at a time, depending on the size of the board, obviously. To improve on the manual temperature control of the preheater, the next logical step is to upgrade the controller to provide some automated reflow. But before we do that, let's start with a teardown. Oh yeah, and before getting started, firstly I must apologise for the lighting and colour balance issues in this video. So I finally did a quick setup for a new recording bench space, software install on a new PC, thinking I'd just live record a quick initial video. Yeah, right. Of course, we all know when you don't test your setup first, you end up with a mess of video issues and audio feedback. Oh dear. Hence why I can apologise up front, because I'm having to re-record as a voiceover. Okay, so with that out of the way, let's get underway. So this is my UYue, if that's how you pronounce it, 946-1010. The 1010 refers to the fact that the heating plate on top is 10 centimetres by 10 centimetres, 10 centimetres square. There's also a 1515 model and a 2020 model, which has the 15 centimetre square and the 20 centimetre square top plate. But for my needs, when I'm mostly doing small boards, I just want it as small as possible, so I grabbed the cheaper 1010. So the first step to opening this up is to remove the base plate, which is screwed in with 4 Phillips screws through the rubber feet. So we'll flip it over and let's get those screws out and remove the base plate. So I did take the base plate off in the previous video. As with any mains powered equipment, I usually like to check the earthing is good before powering it on. You do that from the externally with a multimeter, but I like to have a look inside and just see what the wiring looks like and make sure there's a pretty robust earth connection. In this case, there is a lug for the earth wire, which is bolted to the case. However, the lug isn't crimped, it's actually open and just soldered on. It's interesting that it's actually bolted to the bolt that goes through to the hot plate. So you imagine it could get quite hot. So I'm not overly happy with that. I'd rather see it crimped, but we can deal with that later. The mains wiring is just bare wires screwed onto the screw terminals. Not ideal. Lugs would be nice there as well. Okay, where to start? The solid state relay is just bolted through the ventilation holes on the side of the case. So let's get that unbolted first. Okay, so these thin wires will be the thermocouple connected to the 2 middle screw terminals, so let's get those unscrewed. Okay, let's get the solid state relay out so we can see how that's connected. Right, so the input side is connected to the 2 side screw terminals. Let's undo those. I've taken a photograph of the inside so I know where everything goes. Okay, yeah, just bare wires, no crimp lugs here. So on the output side we can see that the neutral side is being switched, and we have 3 wires going in there, so I'm guessing there's going to be 3 elements wired in parallel. So let's get the solid state relay fully disconnected. This is a 220 volt rated preheater, which the label indicates draws 600 watts. Therefore you'd assume the 3 elements are perhaps rated 200 watts each, but we'll see shortly. I'll just retighten that terminal and unscrew the mains neutral wire. And that's the SSR out. Next, let's take out the main switch assembly. There's 2 Phillips head screws to remove. This is an all-in-one IEC socket with integral fuse and power switch. Okay, let's see. I'll pop the connectors off the back first. First the active wire. It's good to see that these are properly crimped connections, not just soldered. Right. Okay, I'll pull off the earth lead next. And finally the mains neutral lead. It's pretty tight. The remaining wire is the active wire link. You can see the active pin on the IEC socket is strapped across to the fuse, with the other end of the fuse being linked across to the main switch. Nice. Right, now let's have a look at the controller. We did have a look at this briefly in the last video. The microcontroller on board. Can't remember what it was, so we'll have another look at that. Let's get it out of the case. So I can see there's 3 screws screwing the controller board onto the back of the display. Actually I can see in there's a screw coming through the metalwork from the front, from the outside, and another one on the other side. Okay, so let's flip this up. This feels like this might be a stuck on front panel. Let me grab a knife. See if I can leverage this up without doing too much damage. I can just feel the edge here with my fingernail. So I'll just slip the blade in the edge there and see if I can leverage this up. Yeah, no, it's going to come off nicely. Just leverage that up a little bit. Try not to damage it. And we'll just peel that back. And yes, there we are, Phillips screw. So there'll be one of these here and one on the other side. Take that one out. And right, all the same size screws. Okay, let's just peel this back a bit. There's the set button. Actually, maybe not. Maybe I'll spin this round instead of peeling the whole front panel off. Just see if I can. I'll leverage up the other side. It's the same. But hard to get the blade in. Try not to do too much damage in case I want to stick it back down again. Let's get the second screw out. and hopefully that should free it up to drop out of the side of the case. Yeah, it's just going to lift out. Nice. Okay, let's just slide this out. I've still got the mains wires connected to the controller board. On the end terminal you can see there's the 3 wires from the other end of the elements, and the active wire that came from the main switch, and on the second terminal we've got the neutral wires. So all these are just bare wires attached to these screw terminals. Certainly not ideal. Probably would have preferred them going through a mains terminal block or something instead of just all hanging on there. I don't see much mains isolation on the circuit board either in terms of separation from the low voltage. Let's spin this round and have a bit of a look, have a bit of a closer look. Just grab me microscope. Pull my microscope in and let's have a look at these chips. Get the output turned on. Right. Okay, so there's the microcontroller. I'll just zoom that in a little bit and tweak the focus. Right, so you can see it's a Nuvoton N76E003 AT20. So let's see if we can pull down the datasheet for that. Here we go. As you can see, it's a 8051 based microcontroller, the good old age-old 8051, Intel based. Let's just scroll down, see if we can find a bit more information about this. Yeah, general description. Okay, 8-bit high performance 8051 based microcontroller. Performance enhanced, as you'd expect, given the 8051 dates back to the early 80s. We've got up to 18 KB of flash. And what else? We've got 256 bytes of static RAM, 768 bytes of auxiliary RAM, 18 GPIO, a couple of 16-bit timers, watchdog timer, timer 3, auto reload, baud rate generator, 2 UARTs, 1 SPI, 1 I2C, 5 PWM output channels. And we've got a 12-bit A to D converter. Yeah, nice little chip. 16 megahertz internal clock. Okay, so we could look at reprogramming this, but I guess that might be a wasted effort depending on how widespread this particular controller is in these preheaters. Anyway, let's just have a little bit of a look around the circuit board, see what else we've got. Okay, right, we've got a LM358, which I believe is a dual op amp. I think that's half of the popular LM324 quad op amp. So just a basic standard op amp there. Few discretes lying around. 7805. So that's the voltage regulator. Where's that? Here we go. 78L05. So that's the 100 milliamp variant of the 7805 linear regulator. I think from memory you needed about 7 volts input due to the dropout. Back to the controller. Okay, let's say goodbye to the controller for now and move on. Let's get rid of the datasheet and the microscope. Let's move this out of the way. Right, let's disconnect the controller and move that out of the way. You'll see I've wrapped a bit of insulation tape around this group of element wires just to keep one end of the element wires together. So noted they don't all go through the same hole in the top of the case. Let's disconnect the mains active wire and element connections. You can see these are just bare wires twisted together under the screw terminal. Okay. Let's just retighten that terminal screw. But I think I'll just leave the neutral wires attached for now. I'll just leave the earth wire attached to that lug for the moment. The design of the preheater has an air gap with spaces between the top metal case holding the heating plate and the lower case containing the electronics, just to help isolate some of the heat transfer. Of course, using aluminium spacers is a good way of conducting heat from that top plate through to the case, so yeah, interesting. Right, let's get the rest of the case apart. Those look like hex drive, maybe 3 or 4 millimeter. Let's have a look. Okay, we'll try a 3 millimeter. Yeah, it's a good fit. It's a 3 millimeter hex drive. Okay, let's get these screws out. There's 4 of them that bolt through to the top platform. Those screws out. And you can see these aluminium spacers. There's 4 aluminium spacers that separate the two parts of the case. Okay, put those spacers aside. Okay, let's get those bolts out. Bit fiddly. Probably easier if I had smaller hands. That one's fallen through. Okay, that's the screws out of the way. Now, these wires, we've got, you can see there's 2 of the element wires go through one hole of the thermocouple wires, and the other 4 wires for the elements go through the other hole. Okay, I'll just pull these wires through the holes in the bottom bit of the case. I don't want to lose the grouping I've got, so I'll have to figure out again which end of the elements are grouped together. Just pull this through and feed this wire back through the insulation tape that's holding those together. Alright, and just pull out the other wires, get rid of the bottom part of the case. Right, so we're down to the top section of the case that contains the heating plate and the elements. There's 4 bolts holding that in. They're bolted into the heating plate itself by the looks of it, and they're the same 3 millimeter hex drive. They're probably the same size bolts as the other ones for consistency. Yeah, they're the same. Only difference being is the These ones are a bit blackened by being screwed into the heating plate. Let's get these out. Last one. Now I could hear a something rattling around in there, so there's probably some spacers floating around that I've taken the bolts out. Let's have a look inside. Okay, we've got some insulation there, and yeah, there's some spacers in there. Look, that one's still stuck. There's a couple have come free. Yeah, they're exactly the same as the 4 spacers that were holding the 2 parts of the case apart. Right. Don't know what that insulation foam is made out of. Okay, so we have 3 elements here. So they're just attached in some channels that are being cut into the heating plate. And we can also see why there's 2 wires coming out of one side and 4 wires coming out of the other side of the case, because of the orientation of those elements. Let's have a look at how thick this heating plate is. It's about 10mm thick piece of aluminium. You see if we can see what's written on these elements. So I'll just grab the USB microscope again so we can have a look and see what rating these elements are. Just zoom this out a bit. Get a bit of focus on here. You can see some writing there. Okay, let's zoom in. That looks like 100 watts. Yeah, there we go. 220 volt, 100 watt element. Okay, so we're going to 3 of those elements. It's going to be 300 watts in total, wide and parallel. While we're here, let's just check the physical size of these elements. So length 59, so 60mm long. Let's just see if we can get the diameter. Try and measure it in this little notch at the end. 7.75, so we'll say 60mm long by around 8mm diameter. 100 watt, 220 volt element. It is interesting that there's 3 100 watt elements giving us a total of 300 watts, because I'm pretty sure this one was advertised as a 600 watt preheater. Let's just have a look. Yeah, there's the label. Power 600 watts. So that's interesting. I doubt whether the controller board's consuming several hundred watts. Be getting pretty hot if it did. Okay, well I think this video has been quite long enough, so we've dismantled the entire preheater and you can see pretty much what makes it tick. Next step for this will be part 3, where I'll try hooking up a alternate controller for some automated reflow and more accurate temperature control. Alright, if you want to see that, then make sure you click subscribe and turn on the bell so you get notified when the next video comes out. That's it. Thanks for watching.